In this video, we are going to see some of the NEET questions asked in previous years. The topic chemical bonding. The question is, which of the following species contains 3 bond pairs and 1 lone pair around the central atom? In the central atom, 3 bond pair and 1 lone pair. The choices given are H2O, boron trifluoride, NH2 minus and PCl3. Now, we are going to see what will be the correct choice. First option given is H2O. This is the structure of H2O molecule, bent structure of H2O molecule. So, undergoes sp3 hybridization, contains 2 bond pair and 2 lone pair electrons. And boron trifluoride undergoes sp3 hybridization. Here all bonded pair of electron, there is no lone pair. So, boron trifluoride sp2 hybridization, 3 bond pair and 0 lone pair. The next structure is NH2 minus. Here the again undergoes sp2 hybridization. Here 2 bond pair and 2 lone pair electrons. So, NH2 minus undergoes sp2 hybridization, contains 2 bond pair and 2 lone pair of electron. And next one is boron trichloride PCl3. This is structure of PCl3 undergoes sp3 hybridization. Here in this structure 3 bond pair of electrons and 1 lone pair. So, for PCl3 it is 3 bond pair and 1 lone pair. The question asked is, which one of the following species contains 3 bond pair and 1 lone pair? So, the answer is PCl3. PCl3 contains 3 bond pair and 1 lone pair. So, in this question, here the species containing 3 bond pair and 1 lone pair is, the answer is PCl3. Next question in chemical bonding is, which of the molecule is a polar molecule? Here the fluoride compounds are given, which of the molecule is a polar molecule? Boron trifluoride, here SF4, SiF4, XeF4, which one of the following molecule is polar in nature? Now, we are going to see the explanation for this. Here in this choices, we are going to see which one is the polar structure having polarity. Here, the structure of the molecule, the symmetry of the molecule determines the polarity of the molecule. Even though the molecule contains polar bond, the symmetry only determines the polar nature, because in the case of if it possesses correct symmetry, the polarity of the one bond get cancelled by the polarity of the other bond which is present in opposite. So, if the molecule possesses proper symmetry, the polarity get cancelled. So, here the structure of boron trifluoride and somewhat proper symmetry, here SiF4 and xenon tetrafluoride. But in the case of SF4, sulfur tetrafluoride, here because of the presence of the non-bonded electron on the central atom and because of the symmetry, it is considered to be polar in nature. So, in the 4 species, SF4 is, because of the on account of the symmetry, here this one is polar in nature. So, here this question, which is a polar molecule, the answer is SF4 based on symmetry. The next question, bond order 1.5 shown by what ionic species? Here the ions of oxygen is given, O2 plus, O2 2 minus, O2 and O2 minus. Now we have to calculate bond order. What we are in need is number of bonding electron, number of antibonding electron by calculating the number of electrons. So now we are going to see which species possess the bond order of 1.5. O2 plus, the first species given is O2 plus. The molecular orbital configuration of O2 plus is 2 oxygen atom, 8 plus 8, 16 electron, plus charge is given, means that is deficient in 1 electron. So minus 1, totally 15 electrons are there in O2 plus. Now if we write the molecular orbital configuration, here the bonding molecular orbital, antibonding molecular orbital, according to the order of energy level for oxygen, the sigma 2pz comes before pi 2px for homonuclear molecule like oxygen. So the order is given 15 electrons. Here these are all bonding molecular orbital. The starred one is antibonding molecular orbital. So sigma 15 electrons, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px, pi 2py both are equal, occupies 2 electron, and in here up to this 14 completed. Here remaining 1 electron goes to pi star 2px1. There is no electron, pi 2py. Now we have to count. Before that, bond order is here number of bonding electrons, number of antibonding electrons divided by 2. So here number of bonding electron is the electron present in the bonding molecular orbital 2, 4, 6, 8, 10. Number of bonding electron is 10. Number of antibonding electron, the starred one, 2, 4 and here 5. So antibonding electrons 5. 10 minus 5. So 5 by 2, 2.5. So the bond order of O2 plus is 2.5. O2 plus 2.5. Now comes to O2 minus. Each oxygen 8 plus 8, 16 minus 1 excess of 1 electron. So plus 1, there are totally 17 electrons. If it is 17 electron means in the order it will goes to here 1 electron, here 1 electron. Here the first according to the orbital electron filling, the next electron 16th electron moves here, the 17th electron goes here, thereby both actually the extra electron goes to antibonding only. So for the O2 minus, the bond order is NB minus NA by 2. Already we have calculated in this number of bonding electron is 10. That extra 2 electron going to antibonding only, thereby here the antibonding electron is minus 7. So 3 by 2, here the bond order is 1.5 for O2 minus. Next one is O2 2 minus. O2 minus means 17 electron. Here the minus means extra 1 electron. Here O2 2 minus means extra 2 electrons, 8 plus 8 plus 2. For each oxygen 8, here the 2 minus extra 2 electron, thereby it is 18. Now this extra electron for 15 here 1 electron and here is empty. For 18 what it will be, extra 3 electron, here 3 electron, 3 plus 1 4, thereby here 2 electron and here 2 electron, both are antibonding. So, in the case of number of bonding and antibonding electron by 2, 10 extra here, the antibonding electrons will be 8. So, 10 minus 8 by 2. For 15 electron, 1 antibonding electrons. Here 18, the 5 plus 3, 8. So, 10 minus 2 by 2, 2 by 2, 1. For O2 2 minus, here the bond order is 1. Here for what is the bond order for oxygen molecule? 8 plus 8, 16. The extra 1 electron moving to antibonding electron, thereby 6. 10 minus 6 by 2, 4 by 2, 2. So, we can say for O2 plus the bond order is 2.5, O2 minus the bond order is 1.5, O2 2 minus the bond order is 1, for oxygen the bond order is 2. What is asked in the question is, what is the species which containing the bond order of 1.5? The bond order 1.5 is O2 minus, the bond order 1.5 is O2 minus. So, for this question, the answer is the bond order of 1.5 shown by, what is the order is O2 minus, this B is the answer.